In question 1a, we have the sum of two cubes. So we have to factor this as our factorization pattern of if we have two perfect cubes, a cubed plus b cubed, we have to factor it into the cube root of the first thing, so the cube root of a cubed, which is a, plus the cube root of b cubed, which is b. Then we multiply it times the first thing squared minus the first thing times the second thing plus the second thing squared. I'm just using the language of, here's my first thing, there's my second thing. First thing squared, the first thing times the second thing, and the second thing squared. The first thing and the second thing are derived by taking the cube roots of your values here and here, your 8x cubed and your 27y to the 15th. Okay, so I talked about these things being kind of two separate units or entities. They really could be thought of that way. So I'm going to look at the numbers 8 and 27. 8 is a perfect cube because it's 2 times 2 times 2, which is 2 cubed, which makes it a perfect cube. 27 is a perfect cube because it's 3 times 3 times 3, which is 27, or 3 cubed. That's what makes those perfect cubes. X cubed is a perfect cube because it's x times x times x. In order to be a perfect cube, you have to be able to take the number times itself 3 times. And a y to the 15th. So what number do I multiply times itself 3 times? So y to the y to the y will give me y to the 15th. Now there's another way of thinking of that same deal. I'm going to finish this thought. It would be y to the 5th times y to the 5th times y to the 5th. Because when you multiply like bases, that's our product rule. You add their exponents. So you add up a 5 and a 5 and a 5. The other way you can think of it is, what is the power that I raise y to? Cube it to get y to the 15th. Well, if I'm going to use my power to power rule, then this would have to be a 5 because then I multiply 5 times 3. Now, when I did these, we said there's an easy way to tell if these are perfect cubes. As long as this exponent is divisible by 3, they will be perfect cubes. As long as they're divisible by 3 means there will be a power that I can raise it to. This 3 times a number will give me the power of 15 that I need. So 3 times 5 is 15. So as long as 3 divides into 15, it will be a perfect cube. So now I'm going to go through and actually do the factorization of that sum of two cubes. So I take the cube root of this first thing. The cube root of 8 is 2. The cube root of x cubed is x. Plus the cube root of 27 is 3. And the cube root of y to the 15th is y to the 5th. That's my first thing, and this is my second thing. So now I take and square the first thing, which is 4x squared. And I'm going to take the first thing times the second thing and multiply them. And it's always going to be subtraction because these signs are always going to be opposite. So I got to take the first thing times the second thing, which is 2x times 3y to the 5th, which is 6x y to the 5th. Then I got to take the second thing and square it. So that's going to be a 3 times 3, which is a 9, and a y to the 5th times a y to the 5th, which is a y to the 10th. This is the factorization of question 1a.